The idea of exploring other planets has always been a dream for humankind, but we have only been able to see it through the lens of literature and cinema. Currently, interplanetary travel requires an extensive amount of time. For instance, a journey to Mars alone would take us approximately 7 months, and if we were to embark on a mission to a different solar system, yeah, you get the point. You see, it all boils down to one thing: energy. Currently, traditional rockets can provide enough energy to leave our planet, but they're not reliable for interstellar travel. That being said, there are other potential solutions, like the use of advanced propulsion systems that could allow spacecraft to travel at a faster speed than traditional rockets. One such system is the nuclear pulse propulsion system, which would use a series of nuclear explosions to propel a spacecraft through space. Another proposed system is the fusion rocket, which would use nuclear fusion to generate energy and propel a spacecraft. However, these technologies are still in experimental stage and face numerous technical and logistical challenges. Plus, there is a faster way: light. Oh, I thought it would be way cooler. But what is light? Well, light is just a group of photons which are individual packets of energy. Due to their lack of rest mass, photons do not experience any resistance from air or gravity and are able to travel at the maximum speed limit of our universe, which is 300 million meters per second. Now you might be wondering, why such a specific number? Because it is. Now, even though light speed has been considered the ultimate speed limit for centuries, humanity has not been deterred from trying to break the law. One way to achieve faster than light travel is by using a warp bubble, a concept first theorized by physicist Miguel Alcubierre in 1994. Definitely butchered that name. You see, by expanding the space behind the starship and contracting the space in front of it, it is possible to greatly reduce the distance between planets and stars that would normally be encountered in travel. In short, you are basically manipulating the fabric of space itself. However, there are significant challenges to creating and maintaining a warp bubble. It would require an enormous amount of energy, equivalent to that of an entire star, which is currently beyond our technological capabilities. Even if we could obtain the necessary energy, maintaining a stable warp bubble would be a major challenge. Any disturbances, no matter how small, could cause the bubble to collapse or explode. Not only that, creating a warp bubble would require an exotic material: negative matter. A hypothetical form of matter, at least for you, with properties opposite to those of normal matter, such as having negative mass, being repelled by gravity rather than being attracted to it. Moving it in any direction would result in it moving in the opposite direction. Oh, and it would also violate some of the energy conservation laws that apply to normal matter, as it would contain negative energy. And no, this is not antimatter. Antimatter has positive mass. Although exceptional work has been done by NASA researcher Harold Sonny White and his team. While investigating energy distribution across wavelengths, they stumbled upon a microscopic experiment that produced enough energy to achieve a form of warp speed. In theory, this development could potentially address the negative energy issue associated with the warp drive technology. But let's get back to the normal world for now. We will come back to it later. It's clear for now that the first method we talked about for traveling faster than light speed isn't exactly the most dependable solution when you're exploring space millions of miles away from home. Fortunately, there is another option that might be better, though it would be necessary to define the term traveling. In essence, traveling involves moving to one location to another. This can be achieved through either traditional linear route require a shortcut. This same principle applies to space exploration. Where taking a shortcut can help space explorers bypass long journeys and arrive at their destinations more quickly, saving valuable time and resources. And that shortcut is a wormhole. Let's go in. A wormhole, also known as Einstein-Rosen bridge, is a hypothetical passage through space-time that may provide a shortcut for traveling vast distances across the universe. Okay, that was fun, but let's not do that ever again. Anyways, the concept of a wormhole was first introduced in the early 20th century as part of the Einstein theory of general relativity. According to this theory, space and time are intertwined and can be bent and curved by massive objects like stars and black holes. Wormholes are thought to be a natural consequence of this curvature of space and time, where two distant points in the universe can be connected through a tunnel-like structures. If this technological breakthrough becomes a reality, it has the potential to significantly reduce travel times for traversing vast distances across the universe in comparison to traditional methods. But hold on, not so fast. There are numerous issues that must be solved first. One major challenge is the immense amount of energy required to sustain a wormhole for an extended period of time. Additionally, the minuscule size of wormholes, potentially as small as subatomic particles, could make transporting large objects like a spaceship through them impractical or even impossible, not to mention the exotic matter it would require, negative energy. See, I told you we would be coming back. However, one of the most pressing issues is the uncertainty of what awaits us at the end of the tunnel and whether we have the ability to control it. And this issue is not only relevant to wormholes, but every other means of travel, simply because we, are still relatively new to space exploration. Now, some of you may wonder why we should even bother with pursuing these theoretical concepts, given there are so many uncertainties involved. However, I feel like perhaps it is only by dipping our toes into the vast and unknown universe that we can uncover new insights and possibilities that will enable us to develop groundbreaking technologies and achieve pioneering innovations. If you like this video, then please press the like button, or if you dislike it, then don't. If you liked it a lot, then consider pressing that red button and join the School of Travelers. New video every month, hopefully. Cosmic Traveler out.